Hello, thank you for watching this video. So in this video we're doing question 3 of November 2022 question paper Physical Sciences paper 1, and these are vertical projectiles. So I'll be reading the statement here on our question paper and then answer the questions that follow. Okay, so I'm going to read the statement now. A ball is thrown vertical upwards from the top of a building of height 25 meters with a velocity of 12 meters per second. On its way down, the ball passes a door which has a height of 1.9 meters and strikes the ground as shown in the diagram below. Ignore the effects of air friction. So, here's our situation here. So, as they are saying, a ball is thrown vertical upwards at this velocity, which is 12 meters per second, from the top of a building which is 25 meters tall. So this ball, on its way down, it passes this door here, is the door, which is the height of 1.9 meters, and strikes the ground. That's what they are saying. So I'm going now, so this is the drawing that I have here on my question paper. So define the term free fall. So they want you to define free fall. So what are free falling objects? That's what they are asking you. So by the term free fall, so those are, I'll say, those are kind of motions in which the only force influencing the motion is gravity only. So it's a type of motion. So free fall is the type of motion in which the only force influencing that motion is the gravity only. There are no other forces like frictions, they're not there, and all other sort of forces that can interfere with the motion. All other forces that you can think of that can interfere with the motion are not there. The motion is only influenced by gravity only, which means the cause of that motion is gravity only. So that's what free fall is. So I'll say this term free fall, it means that it refers to a motion in which gravitational force is the only influence or the cause of that motion. That's how I can define it. I don't think I will have to write it down. So let's go to 3.2. So I'm not going to write that down. It's straightforward. So 3.2. Calculate the time it takes for the ball to reach its maximum height. So they want us to calculate the time the ball takes to reach the maximum height. So when you're doing this kind of calculation, I think it's very important to have a coordinate system, right? Let me go and get another marker. So when you're dealing with vertical projectile motions, it's important to have a coordinate system, right? So let's draw that here. So here is our coordinate system. It's like this, right? So anything that goes up is positive, because these are vertical projectile motions. We don't need this one really. So everything goes up is positive, everything going downwards is negative. So if it's going down, it's negative. This is my coordinate system. What else? So I have this point here, this point here. I take this point as a 0 point, right? So for me, any displacement above here is positive, any displacement below here is negative, where my ball starts. So if you have a displacement, I should have a positive displacement here. If I have displacement here, I should have a negative displacement. This is consistent with my coordinate system, which I have here. Okay, so now let's do question 3.2.1. Question 3.2.1. That's like saying calculate the time taken for the ball to reach its maximum height. So they want us to calculate the time the ball takes to reach its maximum height. So they want to find the time to reach maximum height. Okay, so there is one thing that you should always know about the maximum height. So when you're saying it's the maximum height, this is the highest possible position that this ball can possibly get to. So in our case, here, this is the highest possible position that our ball can get to, right? The reason it cannot continue any further is because it does not have the capacity, it does not have the velocity to continue going forward. That's why it is the maximum position. At the maximum height, the ball is lacking the velocity to go further up. So at that point, at the maximum velocity, you should always, at the maximum height, you should always know that the velocity is 0. So here, at the maximum height, V is equal to 0. V at maximum height, you should always know that it's 0. If you're at maximum height, the velocity is equal to 0 meters per second. So you should always know this. The reason the height is the maximum there, it means that the ball cannot go any further because it doesn't have the capacity. The velocity is not there. The velocity is 0. You should always know this. Once you have this in mind, then you won't have any difficulties because you know that Vf equal to Vi plus A delta t, where your A is your gravitational acceleration. You know that your gravitational acceleration is A is equal to 9 meters per second, right? But a gravitational acceleration is a vector, so it has magnitude and direction. That is the magnitude, right? Let me fix this A. This is the magnitude, right? But the direction we haven't indicated. If you're saying it's positive, that means our gravitational acceleration is going upwards according to our coordinate system. If we leave it like this, this tells us, according to our coordinate system, our gravitational acceleration is upwards, but our gravitational acceleration is downwards towards the center of the Earth. So we said any vector that is has a motion downwards or that has a direction downwards, it should be negative. So our gravitational acceleration is negative 1.8. Our gravitational acceleration is negative 9.8 meters per second. That is our gravitational acceleration. 9.8 is the magnitude, which is the size of the acceleration, and the negative sign is telling you the direction because we said all the vectors that are pointing downwards, all the vectors pointing downwards will be negative. All the vectors pointing upwards will be positive. So in our case, our gravitational acceleration is downwards towards the center of the Earth, so it should be negative. That is your gravitational acceleration. So we get to this. So here, this is your final velocity. So your final velocity will be at your maximum height in this case. So your final velocity will be 0 at your maximum height. And then here, this is your initial velocity. The velocity that you started with, which was 12 meters per second. And then t is the time that you're looking for. So your final velocity is 0 here. Then you say 0 is equal to. Then your initial velocity is the velocity you started with. It's this one here. Should it be negative or should it be positive? It should be positive because it's going upwards. And we said from on our coordinate system, all vectors going upwards should be positive. So it should be positive 12 meters plus our gravitational acceleration. Our gravitational acceleration is 9.8 meters per second downwards. So we said down is negative, so it should be negative 9.8 times delta t. So transpose the 12 minus 12 is equal to negative 9.8 delta t. Then divide by negative 9.8. Divide by negative 9.8. So delta t the time to reach the maximum height should be this of negative 12 over negative 9.8. Negative 12 over negative 9.8. So it's 1.22. 1.22 seconds, right? So what this tells you is the ball, it took 1.22 seconds to reach the maximum height. So to reach this point here, the maximum height, it took t is equal to 1.22 seconds. That's all it took to reach the maximum height. We're done with this one. Then we can go to the next question. What does the next question say? Calculate the velocity with which the ball strikes the ground. So they want us to find the velocity on which our ball will strike the ground. So they want us to find the velocity here, at this point here. That is what they want us to do. So what do we know? We know that this ball left there at this time, right? It left at 12 meters per second. We know its initial velocity, but we don't know its final velocity here at this point. But what we know is that, so this is 3.2.2. So what we know is the ball left the top of the building at 12 meters per second. We don't know what was the final velocity there. It's what we're trying to find, right? So what we can say is, okay, since we're in this situation, we know that in total the ball is displaced. The displacement of the ball is this one here. It's 25 meters. So the displacement, right, or delta y, is the change in position. The change in position. So this diagram here, if you look at it, they are trying to draw this such that you can at least try to visualize this. But if you are looking at the actual motion here, if this is the top of the building, this position here, let me just draw it. If this is the top, if this is the building here, so the person's head who's throwing, I would say is somewhere here, right? So they throw the ball, it goes up, right? And then the ball comes down, directly down. So it's not like the person threw the ball like this, like throw it away and then it moves that way. Because if you throw it away, that ball is no longer moving vertically. It's also moving in the horizontal direction. So if this is you here, and you throw the ball away like this. So this ball will have an X component and a Y component. So it has the X and Y component if you are projecting it at this velocity here. But what happens on the vertical projectile motions, you throw something vertical up and then it comes down. That's what happens. But these kind of drawings, two-dimensional kind of drawings, are just there for you to be able to visualize what is really happening. But that's not how it actually happens. You throw something up and then it goes down. That's a vertical projectile motion. So if I'm here and I throw this thing, this marker up, it will go up and then down. That's how vertical projectile motions work. So if my ball is here, I throw it up, go up, and then it goes down. That's vertical projectile motion. It's not moving like this, not thrown away to move in two dimensions. It's just vertical, then go down. So now, if you're looking at this, if the ball is here, and then it's thrown vertical up, and then it goes down, the change in position is this point to that point. From this level to this level. That's the change in position. Because going up, all the displacement, so when you turn your ball to go up, it went all the way up to the top, And this was the displacement because it is a change from rest position. So this is the rest position or the initial position, right? So if it comes down, it returns exactly where it was coming from. So when you're in this position where you started, the displacement is 0 because you have not been displaced from the original position. Then when it goes down, then your displacement, now you change the position. Here is your final and that is your initial. So this should be a displacement. So if you're looking at this, your ball starts here, right? It goes up, it goes up, it goes down, it returns to its original position. So the displacement is 0 here. When it goes down to the ground, then this position where it started, the position where it started to where it is, then that is your displacement. That's how far the ball is displaced from where it started. So you know your displacement, which is the change in position, is 25 meters. But our 25 meters is below where the ball started. So our 25 meters is negative according to our own coordinate system. So now we have the displacement. We have the initial velocity, right? Or we have the initial velocity. So what is the final velocity? That's what we're doing. I'm going to clear this part. So to find our final velocity, we say okay, we say Vf squared, which is what we want, is equal to Vi squared plus 2a, which is the gravitational acceleration, delta y, which is our displacement, which is the change in position. So we want this part, Vf squared, we don't know what this is, equal to Vi. What is your Vi? Vi is the initial velocity of the ball. What was it? It was 12 meters per second. Is it negative or positive? It's going up, so it is positive according to our coordinate system. So this is 12 squared plus 2a. What is a? A is our gravitational acceleration of 9.8 meters per second. So, is it negative or positive? Our gravitational acceleration is always downwards towards the center of the earth. So, according to our coordinate system, it's going downwards, so it is negative. So we have here negative 9.8 meters per second times your displacement. What is your displacement? Your displacement is the change in position. How much change in position from where the ball started? So the change in position from where the ball started is 25 meters because it will be your final minus your initial position. So that is 25 meters. But it is below. So this 25 meters is below where my reference point where I started. So everything below this point to me is negative. So this will be minus 25 meters. Then you punch this in a calculator. Vf squared is equal to, then punch that in a calculator. I'm going to do that. So 12 squared plus 2 times minus 9.8 times minus 25. So this is 634. Let's see. 634. Then take the square root of this, the square root of that. So your final velocity at which the thing hit the ground is the square root of this answer here. 25.18 meters a second. So this is the final velocity at which this thing hits the ground. And velocity is a vector. So I'll say that 25 meters per second downwards. That's what I'll say. So it's a vector to have magnitude and the direction, or towards the ground, whatever way you are comfortable with. Let's go again. So calculate the time it took for the ball. Calculate the time it took for the ball to move from the top of the door to the ground. Okay, let me read this again. Calculate the time it took the ball to move from the top of the door to the ground. So they want us to calculate the time it took our ball to move from the top of the door to the ground. So they want this time here. They want this time here. The time from where this thing got to this time there. So How much time did it take for the ball to move from this 1.9 meters to down here, down there? How do you do this? Okay, so let's enter this information here. What I'm going to do is I'll say, okay, our ball reached here at 25.18 meters per second. So this was our final velocity at which this thing hit the ground, and that was our initial, and that was the time it took to reach the maximum height. I'm going to clean the board because I think I'll need more space for this one. Let's clean the board. Then we'll do 3.2.2. Okay, so I'll read this question again. Calculate the time it took the ball to move from the top of the door to the ground. So they want the time it took to move from here to here. That is what they want. So there are many ways to look at this. There are many ways to look at this. So what I suggest we do is we do something similar to what we did here. Right? Because what we did here, we're given the initial velocity, we had the displacement, and we found the final velocity there. So what I suggest that we do is, let's find the final velocity at this point, right? So let's try to find the final velocity from here. The final velocity here, if you start from here. What is the velocity if you start here at 12 meters per second and go to this position here? Once you get that final velocity there, then we can calculate how long did it take this velocity to move from whatever it is there to this 25.18 meters per second. So that's how I would look at it. I'll say let's find our final velocity here. What was the velocity when the ball reached the top of the door? Once you have the velocity at which the ball reached the top of the door, then you can ask yourself, how long did it take for the ball to move from that velocity to this velocity that we have here? Then let's do that. So, we use a similar technique as in the question above. You say, okay, I have the initial velocity, I have the displacement here. So our displacement here, we said the displacement from there to the ground is 25 meters because from where we started to where the ball ended is 25 meters. And we said it's negative because it's below our point of reference, which is the top of the building. Now, if you move from here to here, then your displacement now will be this one here. This will be displacement. This will be a displacement here. How are you going to get that? You'll say, okay, from my 25 meters, I'll subtract the 1.9. That will give you the top of the door. How far the door is from our point of reference. So we say, okay, 25 meters minus 1.9. Right? So it's 23.1. So this displacement here, from where the ball started to the top of the door, is 23.1 meters. So now you will calculate the velocity now of the ball after it has been displaced to 21.3 meters, 23.1 meters. After it has been displaced to 23.1 meters, then you will know what velocity will it reach the top of the door. Once you know what velocity does it reach the top of the door, then now you will calculate how long did it take that velocity to move from whatever it is to whatever value you get there to that 25.81. Then you must find the time it takes to pass the door, which is what you need, I believe. The time it took for the ball to move from the top of the door to the ground. So let's do that. Let's find the final velocity here. So we'll say, okay, the final velocity there, 3.3.3 or 3.2.3. Vf squared is equal to Vi squared plus 2a delta y, right? So our Vf is what we're looking for there. So Vf squared is equal to Vi. What is our Vi? Is our initial velocity. Is it positive or negative? It is positive because it's going upwards. So it's positive 12 plus 2 times gravitational acceleration. What is our gravitational acceleration? It's 9.8 meters per second, which is what? Is it negative or positive? It's going downwards, and according to our coordinate system, it's down, so it's negative 9.8 times your displacement. What is your displacement? Displacement, it is the change in position. How much did our ball change position from its starting point? So it went up. So this will be displacement when it's up at the maximum height, and then it went down. Then the displacement here is 0 because it has not changed position. Then when it goes down here, then it's at 23.1 meters. And then if you continue going down, then you add that 1.9, you get the entire 25 meters. So your displacement is 23.1 meters. Then and it should be negative because it's below our point of reference, which is where the ball started. Right? Then you punch that in the calculator. Say okay. This guy here should be squared. So you're saying 12 squared plus 2 times negative 9.8 times 23, negative 23.1. The answer is Vf squared is equal to what? 596.76, right? Then you take the square root of this, square root of that. So your final velocity is equal to, then you take the square root of that. So it's 24.43 meters per second, downwards. Because it's going down, it's a velocity. It has magnitude and direction. Okay, so now we know that at the top of the door, right, the velocity here is that. At the top of the door here, the velocity is 24.43 meters per second. That's the velocity at the top of the door. Then now, you ask yourself, how long did it take for your ball to move from the top of the door to the ground? That's the time that you are asked to find. So what you're going to do, you're going to say, okay, I have that Vf is equal to Vi plus A delta T. This is your final velocity, and your final velocity will be your velocity at the ground. This will be your final velocity. Vf will be final velocity at the ground. You know it's this thing here. Your initial velocity, now you take this as your initial velocity because this is where you are starting now. This, you have your initial velocity. This is the gravitational acceleration, and this will be your time that you need, or that you are asked to find. So your final velocity is what? Is going downwards, so it should be negative 25.18 is equal to initial velocity, which is also downwards as well, right? So it's negative 24.43 plus A. Your A is your gravitational acceleration, which is a downwards vector as well, which is negative 9.8 delta T. Then you solve for your time, and that time that you will get will be the time from the top of the door to the ground. Then you punch that in a calculator. You say, okay, so it's going to be, solve this first. So negative 25.18 plus 24.43 is equal to negative 9.8 delta T. 95 by negative 9.8 divided by negative 9.8. So delta T, which is the time, is equal to what now? Just punch this. So minus 25.18 plus 24.43 over negative 9.8. This is equal to 0.08. seconds. This is your time. So this is the time it took for the ball to move where? To move from this top of the door to the ground. 0.08 seconds. That's the time that you have. What do? You say, okay, now. Okay, so what do you do now? You say, okay, we're done with this question. So the ball, it took this time to move from there to there. And you go to the next question. So, 3.3. Read as follows. Draw a velocity versus time graph for the motion of the ball from the moment the ball was thrown upwards until it strikes the ground. Use the ground as zero reference. Okay? Indicate clearly the following on your graph. The velocity, so these are things they want you to indicate. The velocity with which the ball was thrown vertical upwards, the time it takes to reach the maximum height, the velocity with which the ball strikes the ground. Okay, so three things that they want you to show. So velocity time graph is it. So you have velocity here in meters per second. You have time here in seconds. So velocity versus time graph. Sure. So they want to indicate the velocity with which the ball was thrown upwards. The ball was thrown upwards at 12 meters per second. And 12 meters per second was what? Was positive because it was going upwards. So we have 12 here. 12 meters per second. What else do they want? The time it takes the ball to reach the maximum height. The ball took 1.22 seconds to reach the maximum height. So here's 1.22 seconds. What else do they want? The velocity with which the ball strikes the ground. So the ground velocity with which the ball strikes the ground. So the velocity was what? Minus 25.18. Minus 25.18. So the most important thing is the shape of the ball, right? So if you're drawing velocity time graph, it's this. It's more like you're putting this function here. This. So if you look at it, it's v of t is equal to v plus a t. So this is your gradient. This is your constant. You're only changing this variable here. So this is a straight line. So you can just say, okay, here's my thing. Yeah. So you've shown the time there. You've shown the velocity, shown the time, shown the initial velocity. So this is your thing. So it's not drawn to scale, but it should be something along these lines. And if you take the gradient, look at the gradient, it's negative, and as it should be, because this was my gradient. If you're saying this is a straight line, it should be gradient is negative. Yeah, should be that. So if you calculate the gradient between this point and that point, it should give you 9.8 or something very similar. This is how you do this thing. Straightforward. Thank you for watching. Easy. Cheers.